So how to use the calculator to calculate a confidence interval to estimate the population proportion P. So we just estimated the proportion of students on financial aid in the question above, right? But we use the formula using z-scores. But there's a function in the calculator that will create this confidence interval for us to estimate P using z-scores. It's in the same menu as where the other confidence interval test was for means. So we're going to press stat. We're going to go over to tests, but now we're going to choose option A, which is a 1 proportion z interval, right? Because we're estimating the population proportion and we're using z-scores. And we have to enter X, the number of observations that possess the particular characteristic, N, which is sample size, and then C, the C level. So let's redo part A, and you'll see the calculator is going to give us the same answer. So X was 118, right? In this case, it was 118 out of N students, which was 200 that got financial aid. And we want to construct a 90% confidence interval. So that's going to be our C level. So let's go over to the calculator. So we're going to press stat, arrow over twice to tests, and you're going to go down to 1 proportion Z interval, which is option A. So you got to keep scrolling. So here's option A, 1 proportion Z interval. So X is how many students get financial aid, right? How many observations have that characteristic that we're looking for? How many students did we sample? 200. And my confidence level in this case was 90% or 0.90. So now we have to calculate. And you see how we get 0.5328 to 0.6472, which is pretty much the same thing that we got when we did it by hand. There's just a teeny tiny bit of rounding error, which is normal. So you see how the calculator gave us 0.5328 to 0.6472. So it's the same to 3 decimal places. There's a little bit of rounding error in the 4th decimal spot over, not a big deal. Always expect a little bit of rounding error. You didn't make a mistake. So now for this next example, I want to use the calculator. So let's look at example 7. So it says Mike's housemate Allie is trying to convince Mike to get a tattoo. Mike is very sensitive to popular opinion and will only get one if everyone else is doing it. Mike will get the tattoo if Allie can show that more than 50% of the students at Mike's college have one. Allie wastes no time in taking a random sample of 120 people from Mike's campus. Her sample of 120 revealed 72 people have a tattoo. So A says, let's find a 95% confidence interval for the estimate of the population proportion of students that have a tattoo. So think about what's going on here. Mike is saying he'll get a tattoo if Allie can show that more than 50% of the students at their college have one. But obviously they can't get that true proportion. They're not going to go to the whole population of students and ask every single one, do you have a tattoo? And then get that percent or that proportion. It's impossible. So Allie wastes no time and takes a sample. And her sample shows that 72 people have a tattoo, 72 out of the 120. So in this case, N is equal to 120, our sample size, right? And then X equals 72 people have the characteristic of having a tattoo. So let's use this information to construct a 95% confidence interval to estimate the true proportion of students at Mike's college that have a tattoo. So since we're estimating the population proportion, we have to do a 1 proportion Z interval in the calculator. So stat over to tests, go down to option A. One proportion Z interval. Now, X in this case is 72, right? 72 said, yes, I have a tattoo. 120 people were sampled altogether. And we are constructing a 95% confidence interval. So my C level is going to be 0.95. And then we have to calculate. And let's go 3 places this time. So it's going to go from 0.512 to 0.688 if we round 3 places. So for part A, the confidence interval goes from 0.512 to 0.688. So we're 95% confident that the proportion of students that have a tattoo is somewhere between 0.512 and 0.688. So between like 51% and 68%. So B, what's the margin of error? So remember, that's just 1/2 the width of the confidence interval. So let's take the width, which is 0.688 minus 0.512, and we divide that by 2. So take the width, which is 0.688, minus 0.512, and divide by 2. So the margin of error is 0.088. So C says, write a statement to interpret this confidence interval. So we are 95% confident that the proportion of students at Mike's college that have a tattoo is between 0.512 and 0.688. Or another way to write that, it's between 51.2% and 68.8%. And we could write that decimal as a percentage. So we're 95% confident that the proportion of students at Mike's college that have a tattoo is between 51.2% and 68.8%. So now the real question is, should Mike get the tattoo? Why or why not? Well, think about what he told Allie. What did he say? He said he'll only get a tattoo if she could show that more than 50% of the students at his college have one. And what did she just show? She showed that it's pretty certain. So we're 95% confident that the proportion of students that have a tattoo is between 51.2% and 68.8%. Which is higher, right, than 50%. The minimum is 51.2%. So yes, he should get the tattoo since this shows that the proportion of students with a tattoo is more than 50%. So yes, he will, since this shows that the proportion of students with a tattoo is more than that 50% that he was willing to risk, right, to get one. And then we'll do one more example. So example 8 says the 95% confidence interval for the proportion of coworkers who went on a vacation last year away from home for at least a week is 0.50 to 0.66. What is the margin of error for this 95% confidence interval? So I already gave you the confidence interval. The confidence interval goes from 0.50 to 0.66. And the margin of error is just 1/2 the width, right? So the width is going to be 0.66 minus 0.50 divided by 2. So we're going to get 0.16 divided by 2, which is 0.08. So the margin of error in this case is 0.08, 1/2 the width of the confidence interval. And that wraps up chapter 9. So chapter 9 is constructing confidence intervals to estimate either the population mean or the population proportion. And you'll have an assignment where, you have to practice calculating these confidence intervals for both. You have to know how to calculate the margin of error, the width, and how to interpret these confidence intervals. And I'm really encouraging you to use the confidence interval functions on the calculator because it's just going to be more efficient. It's going to take less time than trying to do the formula by hand, and it's less likely that you're going to make a mistake. So the next lecture that we're going to begin is on hypothesis tests. So you'll see that I bundled chapter 10 and 11 together as one unit because both chapters are on hypothesis tests. So we're going to do them together. So starting next lecture, we're going to introduce hypothesis testing.